This time we're being asked to prove or disprove that for all integers a, b, and c, if a divides b and a divides c, then will it necessarily be true that a divides 2b minus 5c? Is that true or is that false? What do you think? Keep in mind that a over b here is not a fraction and a over c here is not a fraction. This is not a over b and a over c. This is a slash b, which means a divides b, or in other terms, b is a multiple of a. So if you chose a number a that divides b and a number a that divides c, will it be necessarily true that a is going to divide 2b minus 5c? So for instance, if a is 4 and b is 20 and c is 12, obviously a divides 20 and a divides 12. Now, what is the solution going to be when I multiply 2b minus 5c? So that's 2 times 20 minus 5 times 12. The total here is going to be 40 minus 60, which is at the end negative 20. Now, the question is, does 4 divide this answer negative 20? And it's clear that yes, it does. As a matter of fact, this is not a proof. This is just a convincing argument that I can make with myself to lean one way or another. In this case, I'm going to lean towards the fact that the statement is probably true, so I must try to prove it next. In order to prove the statement, I'm going to begin by writing let a, b, c be integers. And furthermore, I want to suppose that a divides b and a divides c. That was the assumption, and my goal is to show that a should divide the difference, 2b minus 5c. Now, by definition of divisibility, since a divides b and a divides c, that means that there are some random integers k and t such that b is equal to ak and c is equal to at. Notice that I did not write any fractions in this problem. Even though this looks like a fraction and a divides c looks like a fraction, we don't write them as a divides c equal to t. That's not what we do. This is not appropriate notation. Remember, the slash symbol is not an operator. This is just to replace the word divides. So it doesn't make sense to say a divides c equal to t. That's just bad notation. Now let's consider the quantity 2b minus 5c, which is the quantity we're interested in. We want to show something is true about it. So let's do some direct substitution and replace b with ak, replace c with at. When we do that, what do we end up with? Well, we end up with 2ak minus 5at. And the special thing to notice here is that there's a repeating twice, which means we can factor it. And the result is 2k minus 5t, which is exactly an integer because k itself is an integer and t itself is an integer. That was by assumption of the word divisibility. This is important because now a times an integer is equal to 2b minus 5c, which means a is going to divide 2b minus 5c by definition of divisibility. And that's exactly what we show this problem.